Hello, my name is Michael Gallus, and I am with the Bluetooth Bicycle Sensor Team, number 36. And my block testing in this video is for the microcontroller code to microcontroller data. It is supposed to send four messages: the x-axis acceleration, y-axis acceleration, z-axis acceleration, and a read switch state. And the protocol is C++. So this is my setup that I have here right now, and it consists of a BLE Nano, which is where all the code presides on an NRF 51822 chip, a 3-axis accelerometer from SparkFun, and a magnetic read switch on a breakout board. So there's also a Arduino, and it is only used for powering purposes. I'm using it to power it with the entire system with 3.3 volts, and that's all I'm using it for the sake of simplicity. So let me plug this guy back in. Alright, and I am also using a D55 magnet, which has about 3900 Gauss field strength. So let's get to it and test it out. So I'll get onto my phone here, and I downloaded a generic BLE scanner app, so I will start that up. And right now it's not showing up because I don't have the system connected yet. So once I plug that in, BLE bike should show up. So I will plug that in. And look at that, BLE bike. So I'll connect to it. And now I created two different services for this project. One is for the read switch state, which is this guy right here, and the other one is for the accelerations, all three of them. And so the read switch state service has one characteristic, and the acceleration has three characteristics: the x, y, and z axis. So if I go here, I will choose read. For this app, it needs to be chosen. And you'll see that my hex value is 0. So if I take my magnet, and the idea here is that the magnet will be on the spoke of the wheel, and every time it passes it, the read switch will close, and there will be a signal to the code and to the phone saying that that was one revolution. So the phone app that we'll be creating will take that data and it'll use it to tell the RPM. So as you can see, I'll try to get it all in one shot here. I will try to, so every time I bring the magnet close to the, so the magnetic switch, you can see that it goes from 1 to 0. Yeah. So that works. There's my read switch state, signifying that a 1 is the read switch is closed. And now we'll take a look at the accelerations. So acceleration service, and then we have our three characteristics. Since it's a generic app, it won't read my titles for the services and characteristics. So let me just choose read for all of those guys. Alright, and you'll see for the x-axis, there seems to be some value when it's just standing still. I'm assuming that is just a calibration that I need to fix, but either that or it's the sensitivity of the accelerometer, which I may change, or I need a new accelerometer which is less sensitive to its environment. But as you can see, X is BD, and Y-axis is BC, sometimes going a little higher than that. And Z is a little higher than that with 803F, with the base 3F. So as I pick this up, the accelerometer should show values that will correspond to how it's being moved. So on the base values, it changes, so you can see that the numbers are changing as I tilt this all around, and as the bike will speed forward, these values will be used to get the accurate speed. So that is the messages for the X acceleration, Y acceleration, Z acceleration. So all three of those show up. They may not be calibrated right, but I was able to get the acceleration sent over to Bluetooth. And for the last one, we have the protocol, which is C++, and I will take you to the embed site, which is where I am programming the BLE Nano. So as you can see, it's a .cpp file with 2 header files, and you can just see that as I go through. The 2 header files are each service. The read switch state service, it just describes what the Bluetooth should be looking for in each one. It should be looking for a read switch state, and then it should be looking for 3 x-axis values, x, y, and z-axis values. And then over in main.cpp, it utilizes those header files. It advertises and sets up the BLE connection with anything. And after it's done setting up, it will update the state of the read switch in interrupt condition, or it will read the accelerometer with an I2C communication protocol, and from that I2C communication protocol, it'll send it directly over BLE and update our phone. So those are all the requirements for this block. It still needs a little bit of adjustments, but it sends the messages and it is used in C++ code. I hope you enjoyed this block test. Thank you for watching.